Hello everyone. In this video, let's discuss how to write a program for factorial of a number. Okay, so first let's discuss the logic of the program. So let's take an input value called 5. So if I want to find the factorial of 5, we have to start multiplying 1 into 2 into 3 into 4 into 5. The output will be 120. This is the factorial of a number. So the logic is pretty simple. For the given n value, I have to start multiplying product from 1 to n. This is the logic of factorial of a number. Now let's go for the implementation of the program. Let's import the util package. Import java.util.start. So to get the input value, I'm using util package. Class main. The execution always starts from the main method. Public static void main string args. Fine. Now I'll create an object for the scanner class. Scanner is equal to new scanner system.in. Fine. I'll take a variable. I'll get the input value from the user. sc.nextInt. Fine. Now I have to take a variable. I have to store the fact value, right? So I'll be taking a variable called fact and I'll initialize the value as 1. I'll tell you why am I initializing with 1 later. So I'll take a for loop because 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. So in other words, I can say that here we are taking 1, okay, and we are multiplying by 2 and it goes on. But first 1 has to be multiplied by some number and that has to be the same number again. That is why I'm taking 1 here. So the fact value 1 will be taken. That will be multiplied by 1, the actual starting number. That will be stored in one variable. That is a variable called fact. Now this value will be taken and that will be multiplied by 2. The value 2 will be stored in the variable fact. Now this result will be taken and that will be multiplied by 3. I'll get the value called 6. This 6 will be taken. That will be multiplied by the value called 4. The value is 24. This 24 will be taken and that will be multiplied by 5. I'll get 120. Okay. So this is the logic behind this. Now let's write it as a program. So here 1, 2, 3, 4, 5. We are multiplying by 1 numbers. So I'll be taking a looping statement. So for int I is equal to 1, I less than or equal to n, I plus plus. Because my starting value is 1, my ending value is n. That's why I'm giving this condition. First, I have to multiply by 1. So fact equal to fact into I. So here fact value is 1. 1 multiplied with I value is 1. I'll get the value called 1. That has to be stored in the variable called fact. Because in the next number I have to multiply by 2. So I will be using the same variable. So 1 into 1, 1 will be stored in the variable called fact. The reason why we are taking the fact value as 1 instead of 0, because I have to multiply 1 with some number and I have to get back the same number. That is why I am initializing the fact value as 1. Now I'll go to the next I value as 2. 2 less than or equal to 5. Yes, condition is true. I'll go inside fact equal to fact into I. Fact value is 1. I value is 2. 1 into 2 is 2. Then I'll go to the next I value. I value is 3. 3 less than or equal to 5. Yes, condition is true. I'll go inside fact into I. Fact value is 2. I value is 3. 2 into 3, it is 6. 6 will be stored in the variable called fact. Then I'll go to next I value. I value becomes 4. 4 less than or equal to 5. Yes, condition is true. I'll go inside fact equal to fact into I. 6 into 4, that is 24. Then I'll go to the next iteration. I value becomes 5. 5 less than or equal to 5. Yes, condition is true. So I'll go inside 24 into 5, that is 120. Then go to next I value becomes 6. 6 less than or equal to 5, condition becomes false. I'll come out of the for loop. Now I'll be printing the fact value. So the fact value is 120. 120 will be printed. That's all. This is the logic of the program. Let's run the code. I'll give the input value as 5. So I've got 120. I'll give the input value 10. See, I've got 3628800. That's all. Now let's discuss how to write a program to find the Fibonacci series. First we have to know what is the logic of Fibonacci series. So Fibonacci series starts with 0 and 1 and the third digit is nothing but sum of the previous two terms. 0 plus 1 is 1 And the fourth term is the sum of previous two terms, that is 1 plus 1, 2. The fifth term is the sum of previous two terms, that is 1 plus 2, 3. Next term is 3 plus 2, 5. Next term is 3 plus 5, 8. Next 8 plus 5, 13. Okay. Now we know what is the first term in the Fibonacci series and the second term in the Fibonacci series. To find the first term and the second term, we can initialize two variables with -1 and +1. So when I have -1 and +1, I can get to know what is my first element in the Fibonacci series, that is 0. And to know what is the second element in Fibonacci series, I'll add these two values. 1 plus 0, 1. So I'll get to know what is the first element in Fibonacci series and second element in the Fibonacci series. Usually Fibonacci series starts with 1. So here what I'll be doing is, I'll be taking two variables. I'll store the value -1 in the variable A and +1 in the variable B. To know what is my first element in the Fibonacci series, I'll add the value A and B. So the value of A and B is nothing but 0. I'll store it in the variable called C and I'll print the value C. Now I have got my first element. So here Fibonacci series, I'll get the value of n from the user. So I'll print n elements. So here let's take the input value as 8. So on the very first iteration, I'll add the value of A and B. I'll get to know my C value and I'll print my C value. Once after printing my first value, I'll change the value. So the value of B will be stored in the variable A and the value of C will be stored in the variable B. So that I can get to know what is my second element. My second element is nothing but sum of previous two terms, 0 and 1. So I'll add A and B. A and B, 1 plus 0, it is 1. So I'll store it in the variable C and I'll print the value C. After printing, what I'll be doing? I'll be changing the values. The B value will be stored in A and C value will be stored in B. So on the next iteration, I'll do sum of A and B. I'll get the value called C. So and it goes on till n times, so that I'll get the n elements in the Fibonacci series. Now let's go for the program. So I'll start with importing the package. Import java.util.star class main. The execution always starts from the main method, public static void main string args. Fine. So I'll create an object for the scanner class. Scanner SC equal to new scanner system.in. Done. I'll get a variable called n. I'll get the input value from the user. So I'll take two variables, int a equal to -1 and b equal to +1. So I'll take a for loop. I'll start the iteration from 1. I'll iterate up to n times I plus plus. So first what I have to do? Sum of two terms, a plus b. So a value, b value will be added and that will be stored in the variable c. So I'll declare the variable int. I have got my first element of the Fibonacci series. After that I have to print that value, system.out.print c. Next what should I do? I have to store b value in a, c value in b and repeat the process. I'll get my Fibonacci series. Let's run the code now. I'll give the input value as 8. See, 0, 1, 1, 2, 3, 5, 8, 13. So initially a value and b value was initialized with -1 and +1. When I add, I'll get the value called 0. That I'll store in the variable c. I'll print the first value c. 0 will be printed. Now 1 will be stored in the variable a and 0 will be stored in the variable b. When you go to next iteration, this will be added. 1 plus 0, the value 1 will be printed. And it gets iterated. That's all. Now let's write a program to find sum of the digits in a number. Sum of the digits in a number. For example, if I give the input value as 413, I need to find sum of all the digits in the number, that is 4 plus 1 plus 3. The value is 8. So the logic is pretty simple. First let's discuss the logic of the program, then we'll write the code. I'll take a variable called sum and I'll initialize the value as 0. Okay. In this variable sum only, we are going to store the final value. So I'll extract the digit, I'll store it in the variable sum. So let's take the value called 413. So from 413, I want to get my last digit. So to get the last digit, when I perform modulus operation with 10, I'll get my value called 3. 413 modulus 10, I'll get the value called 3. So after extracting the digit, that should be added with the variable called sum. So 0 plus 3, I'll get the value called 3. So now you'll get to know why am I initializing the variable sum with 0. Because if I take any value, if I add with any number, I should get back the same number. In that case, I can add only with 0. That is why I'll be initializing the variable sum as 0. Now I have taken the last digit, I have added in a variable. Now I have to remove the last digit. How can I remove? 430 divided by 10, my quotient value is 41. Okay. So this process has to be repeated. Now what I'll be doing? 41 modulus 10, I'll get the remainder value called 1. So I have extracted my last digit. So this should be added with the variable called sum. What is the sum value? 3. So 3 plus 1 is equal to 4. Now what I'll be doing? I'll be removing the last digit. So 41 divided by 10, I'll get the value called 4. Repeat the process. 4 modulus 10, I'll get my remainder value as 4. So this should be added in the variable called sum. So sum value is 4. 4 plus 4, it is equal to 8. Now I have to remove the digit. So 4 divided by 10, it is equal to 0. So I've got the value as 0 now. Now we will have a question. When to stop this iteration? So until the input value becomes 0. When the value becomes 0, I cannot proceed further. Let me stop it. Why am I not proceeding further? Because we don't have any digits further to proceed. So that is why until the input value becomes 0, I'll be repeating this process. This is the logic of the program. Finally, I'll print the value that is stored in the variable called sum. So the value of sum is 8. 8 is the answer. Now let's write the program. As usual, I'll start by importing the package. Import java.util.start. Class main. Public static void main string args. I'll create an object for this scanner class. Fine. Next, what should I do? I have to get the input value from the user. Fine. Now I'll take a variable called sum. I'll initialize the value as 0. I'll take a while loop and I'll start the iteration until the input value becomes 0. Okay. Fine. So in the while loop, I'll be giving a condition saying that while n not equal to 0. So I'll be iterating the loop until the condition becomes false. So I'll take a variable called remainder. I'll extract the last digit. So after extracting the digit, I have to store it in the variable called sum. So sum equal to sum plus remainder. Now I have to remove the digit n equal to n divided by 10. So let's assume I'm going to take the input value as 123. Okay, let's assume the value of n is 123. 123 not equal to 0? Yes, condition is true. I'll go inside. I'll find the remainder. So 123 modulus 10, I'll get the value as 3. Now I have to add it to the variable called sum. That is 0 plus 3 is equal to 3. Now I have to remove the digit. How can I remove the digit? 123 divided by 10, it becomes 12. I'll go for the next iteration. N value becomes 12. 12 not equal to 0? Yes, I'll go inside. So 12 modulus 10, the value is 2. I'll add it with this variable called sum. Sum is equal to 3. 3 plus 2, which is equal to 5. Now I have to remove the digit. 12 divided by 10, it becomes 1. I'll go to the next iteration. N value becomes 1. 1 not equal to 0. Yes, condition is true. I'll go inside. Remainder equal to n modulus 10. So 1 modulus 10, the value is 1. Sum equal to sum plus remainder. 5 plus 1, which is equal to 6. N equal to n divided by 10. 1 divided by 10, the value becomes 0. Then go for next iteration. N value becomes 0. 0 not equal to 0. Condition becomes false. I'll come out of the loop. I'll print the variable called sum. That's all. Let me run the code. I'll give the input value as 418. Yeah. See, 13 is the answer. 8 plus 1, 9. 9 plus 4, 13. That's all. Hello everyone. In this video, let's discuss how to write a program to check a number is a palindrome or not. Okay. So to write a program, first we have to reverse the integer. So first we have to get the input. Okay, now store the input in another variable. Okay, after that reverse the given integer value. Now we have to compare the stored input and the reverse value. If both are same, it is a palindrome, else it is not a palindrome. This is the logic. Okay, first we have to know how to write a program to reverse an integer. Okay, if we get that, we can solve this program very easily. Fine. So the logic of reversal is pretty simple. Let's take the input value to be 123. Now first we have to reverse this to 321. So to reverse this, first I'll take a variable called reverse. I'll initialize the value with 0. So in this variable only we are going to store the reversed value. So here this is 1th term, 10th term, 100th term. So we have to multiply the value by 10 each and every time. Okay. So first I'll extract the digit, which is 123. Modulus 10, I'll get the value as 3. So I have got my first term. Now this should be in the 1st term, but in the remaining iterations I will be multiplying the value by 10. So first what I'll be doing is I'll take, okay, the reverse value as 0. The reason why we are taking reverse value as 0, because the first term whatever I am taking, that should be in the 1st term. That is why I'll take the reverse value, that 0 is multiplied by 10, and I'll be adding the digit which we have got. So reverse value is 0, that is multiplied by 10, it becomes 0. So I'll be adding the digit, so which is nothing but 3. I've got the value called 3. Next, I'll remove the digit called 3. So 123 divided by 10, it becomes 12. Now repeat the process. So 12 modulus 10, I'll extract the digit, it is 2 now. I'll extract the digit, that is 2. Now what I'll be doing, this 3 has to be moved to 10th term and this 2 should be in the 1st term. So this 3 will be taken and that will be multiplied by 10 and I'll add this digit, it becomes 32. In the first case, why we are multiplying 0 into 10 in the sense, because the 3 whatever we are getting, that should be the 1st term. That is why initially we are taking the value 0, that is multiplied by 10, that is 0. So we will get the 1st term 3. Now I have got the second digit. When I am getting the second digit, this 3 should be moved from 1st term to 10th term. So I can write like here, initially 3 I have got, now I have got 3 and 2. So this 3 will be moved from 1st term to 10th term. So that value will be taken, multiplied by 10, and that will be added with the digit which we have got. So it becomes 32. Now from 12 I have to remove the last digit. So divide by 10, it becomes 1. Repeat the process. 1 modulus 10, I'll get the value as 1. Now what I have to do? This 32 I have got. This 3 from 10th term should move to 100th term. 2 from 1st term, it should move to 10th term. So it becomes 321. So for that, what I'll be doing? I'll take this value 32. That should be multiplied by 10, which becomes 320. Added with this remainder 1, which is equal to 321. Next, what I'll be doing? 1 value is divided by 10 cut. Now the value is 1 is divided by 10, it becomes 0. Okay. That's all, we have reversed the value. If you want to print reverse of a number, you can directly print this. If you want to check for a palindrome, you can check the reversed value with the input value. If both are same, it's a palindrome, else it is not a palindrome. Now let's go for the program. I'll import the package. Import java.util.star class main. I'll give public static void main string args. I'll create an object for the scanner. Scanner is equal to new scanner system.in. Fine. What I'll be doing, I'll get the input value from the user. Is equal to next int. Now I'll take a variable temp. I'll store this value. I'll tell you why we are storing this value at the last. Fine. Now I'll take a loop. Until this value becomes 0, I have to repeat the loop. So n not equal to 0. First I have to extract the digit. Remainder equal to n modulus 10. I have extracted the digit, that should be multiplied with 10, right? So for that I will be taking a variable called reverse. I'll initialize the value as 0. So reverse will be multiplied by 10, that will be added with the remainder. This value should be stored back to the same variable called reverse, because the next time this value will be taken multiplied by 10. So that is why I am storing back to the same variable called reverse. Now I will divide the value by 10 so that we have removed that particular digit. This process gets repeated. Now I will take the input value called 123. 123 not equal to 0, condition is true. I will go inside. I'll extract the digits. 123 modulus 10, it becomes 3. I have removed the digit. Now I have to multiply. So that is 0 into 10 plus 3, which is equal to 0 into 10 is 0 plus 3 is 3. Now we have to remove the digit. So 123 divided by 10, it becomes 12. Then go for the next iteration. N value becomes 12. 12 not equal to 0. I'll go inside. So 12 modulus 10, it becomes 2. Now reverse value is 3. 3 into 10 plus 2. 3 into 10 is 30 plus 2 is equal to 32. Then I'll go inside. Then 12 divided by 10, it becomes 1. Then I'll go for next iteration. N value becomes 1. So 1 modulus 10. So 1 modulus 10, the remainder value is equal to 1. Reverse into 10 plus remainder. 32 into 10 plus remainder value is 1. So which is 320 plus 1 is 321. 1 divided by 10, it becomes 0. Check the loop again. 0 not equal to 0, condition becomes false. So I'll come out of the loop. To check whether if it is a reverse number, directly I'll print system.out.print ln, I'll give reverse. This is the logic of reversing an integer value. Now if I want to print whether the number is a palindrome or not, now I have to compare the reverse value with the input value. So input value is stored to the variable n, but after this iteration n value becomes 0. But I want to compare it with the input value. That is why I am copying the input value before reversing into the variable called temp. So now I will take the input value from the variable called temp. If both are equal, I will print yes, it's a palindrome, else I will print no, it's not a palindrome. That's all. This is the logic of the program. Let's run the code now. I'll give the input value is 123. 321 is a reverse value. It is not a palindrome. I'll give the input value as 121. 121 is a reverse value. Yes, it is a palindrome. That's all. Now let's write a program to check a number is a strong number or not. Let's discuss the logic first. First, let's take the input value called 145. The logic is sum of the factorial of the given digits. So 1 factorial plus 4 factorial plus 5 factorial. So 1 factorial value is 1, 4 factorial value is 24 and 5 factorial value is 120. So now if I add these values, I'll get 145. So I have to take this sum value, I have to check with the input value. If both are equal, it is a strong number, else it is not a strong number. This is the logic of strong number. I'll repeat. So I have to take the input value, I have to find the sum of the factorial of the given digits. 1 factorial plus 4 factorial plus 5 factorial. I'll have the value called 1 plus 24 plus 120. The sum value is 145. If the sum value and the given input value both are same, I can say that it is a strong number, else it is not a strong number. This is the logic. Now let's go for the program. So I'll import a package called util to get the input value from the user. Class main. The execution starts from the main method. Public static void main string args. Fine. I will create an object for the scanner. Scanner is equal to new scanner system.n. Fine. I will get the input value from the user. Int n equal to sc.nextInt. I will copy the input value in one more variable called temp, because after the iteration the input value n becomes 0. I have to compare the value with the given input value. So I will copy the input value in one more variable. Now I will take a while loop. I will give the condition n not equal to 0. So until the input value becomes 0, I have to iterate, because we have to find sum of the factorial of the given digits. I have to extract one digit. So for that I will take a variable called remainder. I'll give n modulus 10. So I have extracted my first digit. After extracting my first digit, I have to find the factorial value. So I'll take a variable called fact is equal to 1. For int I is equal to 1, I less than or equal to rem I plus plus. So here for this remainder value, I have to find the factorial. So fact is equal to fact into I. For example, if the input value is 145, I'll extract a digit, that is 145 modulus 10, I'll get the value called 5. Now for this value 5, I have to find the factorial. So when I find factorial for 5, I'll get the value called 120. This 120 should be added with 0 and that should be stored in a variable. For that, I'll take a variable called sum. I'll initialize the value as 0. So here what I'll be doing, sum equal to sum plus fact. So sum value is 0, fact value is 120. 0 plus 120 equal to 120. What I'll be doing, after this I'll extract the digit. I'll remove the digit, sorry, not extract, I'll remove the digit. So 145 divided by 10, it becomes 14. Now we'll go for the next iteration. N value becomes 14. 14 not equal to 0, yes, condition is true. I'll go inside. So 14 modulus 10, the remainder is equal to 4. Now again fact value is initialized to 1. I'll find the factorial value for 4. So when I find the factorial value for 4, the value will be 24. So now sum equal to sum plus fact. Sum value is 120. Fact value is 24, which is equal to 144. I'll go here. I'll remove the last digit 4. So 14 divided by 10, it becomes 1. Go for the next iteration. N value becomes 1. 1 not equal to 0. Yes, condition is true. I'll go inside. Remainder equal to n modulus 10. So n value is 1. 1 modulus 10. The remainder value is 1. Now I'll find factorial value for 1. After finding the factorial value, I'll get the value as 1. So I'll add it with the sum value 144 plus 1, which is equal to 145. Now n value becomes 0. 1 divided by 10, it becomes 0. Go for the next iteration. 0 not equal to 0. Condition becomes false. I'll come out of the while loop. Now what I have to do? I have to compare the sum value with the temp, because after the iteration, after this iteration, input value n becomes 0. So I have copied the input value in one more variable called temp, that will be compared. Now I'll print, if both are equal, I'll print it is a strong number. So I'll give yes. If both are not equal, I'll give it is not a strong number. That's all. Let me run the code now. I'll give the input value as 145. Yes, it is a strong number. I'll give the input value equal 123. No, it is not a strong number. That's all. Now let's write a program to check a number is an Armstrong number or not. Okay. So here most of us are thinking the logic of Armstrong number in a wrong way. Let's discuss that in detail. So most of us will take the input value is 153. So we feel that 1 cube plus 5 cube plus 3 cube. The value is 1 cube value is 1, 5 cube value is 125, 3 cube value is 27. So I'll get back the value, sum value was 153. The sum value and the input value both are same. So we are saying that it is an Armstrong number. This logic is correct. But we should not cube for all the digits. This is one thing we have to know. So for 153 we have to cube, but not for all the numbers. Let's take the input value as 1634. In this scenario we should not cube. So for the power value we have to find the number of digits. So for 153 it is a 3-digit number, that is why we are cube. We are giving the power value is 3. But 1634, the number of digits is 4. So we have to raise the power value as 4 here. So 1 power 4 plus 6 power 4 plus 3 power 4 plus 4 power 4. 1 power 4 value is 1. 6 power 4 value is 1296 plus 3 power 4 value is, this is 9, 27, 81. 4 power 4 value is 4 4 16, 64, 256. If I add all these value, I'll get back the value called 1634. So I can say that it is an Armstrong number. This is the correct logic of Armstrong number. Okay. So to solve this program, first I have to find the number of digits. After finding the number of digits, I have to extract each and every digit I have to raise the power value for that digit by the number of digits, and I have to sum all the values. After summing, if the input value and the sum value what we have got both are same, I can say that it is a Armstrong number, else it is not an Armstrong number. Fine. Let's go for the program. First, I'll import the package util to get the input value from the user. Class main. Public static void main string args. Okay. So I'll create an object for the scanner class. Scanner is equal to new scanner system.in. Fine. I'll get the input value from the user sc.nextInt. I'll copy the input value in a variable called temp. First, I have to find the number of digits. Okay, so I'll take a while loop. I'll give n not equal to 0. So to find the number of digits, I'll remove one digit. When we are removing one digit, I'll take a variable called count. I'll increment the value. So here, I'll take the input value as 1634. Okay, here I'll give 1634 is the input value. That is not equal to 0. Yes, condition is true. I'll go here. I'll remove the digit. How can I remove the digit? N equal to n divided by 10. That means 1634 divided by 10, it becomes 163. I have removed one digit. So I'll take a variable called count. I'll increment the value. So I'll initialize the count value as 0. So now count value becomes 1. I'll go for next iteration. It becomes 163. 163 divided by 10, it becomes 16. So I have removed one more digit, so count value is incremented by 1, it becomes 2. I'll go for the next iteration. Input value becomes 16. 16 not equal to 0, yes, true. I'll go inside. 16 divided by 10, it becomes 1. I have removed 6. So I have removed my third digit, so count value becomes 3. I'll go for the next iteration. Input value becomes 1. So 1 not equal to 0, yes, I'll go inside. 1 divided by 10, it becomes 0. So count value becomes 4. I'll go for next iteration. N value becomes 0. I'll come out of the loop because 0 is not equal to 0. I'll come out of the loop. Now count value is 4. We have got the number of digits. Fine. Now after this iteration, input value n becomes 0. So I have copied the input value n in one more variable called temp. So I'll store back to the variable n itself because now I am going to the exact logic of Armstrong number. So for that we have to take a loop. I'll give the condition as n not equal to 0. Because we have to find sum of the digits to the power. So for that, first I have to extract the digit. Int remainder equal to n modulus 10. So I'll take the input value as 1634. Okay. Now 1634 modulus 10. I'll get the remainder value as 4. Now what I have to do? I have to raise the power value. Okay. So for that, I'll take a variable called sum. I have to store the value, right? So int sum is equal to 0. I'll get. So sum is equal to sum plus math.power. So remainder value should be raised to the power of the count. That's all. So here power function I have used. Remainder value is 4. 4 power count value is also 4. 4 power 4. The value is 256. That will be added to the variable called sum. So 0 plus 256. The value is 256 I have got. Here I have got an error because power function returns a value in double, but I am trying to store it in a value called integer. That is why I am getting an error. So I will typecast into integer. So this value I am typecasting into integer, so I will not have any error now. I will go to the next iteration. I will remove the digit n equal to n divided by 10. So n value is 1634 divided by 10. It becomes 163. I will go for the next iteration. N value becomes 163. I'll go here. I'll remove the last digit. 163 modulus 10. The value becomes 3. I'll go inside. Sum is equal to sum plus sum value is 256 plus remainder value is 3. 3 power 4. 3 power 4. The value is 81. So 256 plus 81. The value is 337. I'll go here. N equal to n divided by 10. 163 divided by 10. It becomes 16. I'll go for the next iteration. N value becomes 16. So I have to find the remainder. So 16 modulus 10. The remainder value is 6. I'll go inside. Sum equal to sum plus sum value is 337 plus remainder value is 6. 6 power 4. 6 power 4, the value is 1296. Some value is 337 plus 1296, the value is 1633. I'll go here, 16 divided by 10, it becomes a value called 1. I'll go for the next iteration, n value becomes 1. 1 not equal to 0, yes, condition is true. I'll go here. So 1 modulus 10, the remainder value is equal to 1. Sum equal to sum plus 1633 plus remainder comma count. Remainder value is 1, count value is 4. 1 power 4, the value is 1. 1633 plus 1, which is equal to 1634. N equal to n divided by 10. 1 divided by 10, the value is equal to 1. Sorry, 0. Because 1 divided by 10, the quotient value is the remainder is 1. So here the value becomes 0. I'll go for the next iteration. N value becomes 0. 0 not equal to 0. Condition becomes false. I'll come out of the while loop. Now what I have to do? I have to compare the sum value with the input value. But input value n becomes 0. That I have stored in a variable called temp. I'll take the value of temp. Now if both are equal, I'll print yes, it is a palindrome. Sorry, it's not palindrome, it's Armstrong number. Yes, it is an Armstrong number. Else I'll print no, saying that it is not an Armstrong number. That's all. This is the logic of Armstrong number. Let me run the code now. I'll give 153. Yes, it is an Armstrong number. 1634. Yes, it is an Armstrong number. 123. No, it is not an Armstrong number. That's all.